Okay, you are to be congratulated. I just want to tell you that, this is an intense course, as you have found. There's a lot to do and a lot to learn, and you've done well getting to this point. I also want to tell you that the next couple of modules actually are really, really busy. So I suggest that you start, as usual, really early, but really focus on getting those reading assignments, reading and participation assignments done, you know, as early in the week as possible to allow yourself to have time to do the labs. And there are going to be a couple of them, a couple of lab assignments in each of these modules. They're now we're going to kind of try to pull all this stuff together right here at the end. And then we'll cover a little bit of this at the beginning of your next class as well and review it a little bit. But there's a lot to pack in right here at the end of the course. So just hang in there. You're doing great to get this far, and when you're done, you're going to have something that nobody can take away from you. That you're going to be able to use. Honestly, programming like this as we move forward, it really does change your brain. It changes the way you see the world. It changes the way you interpret even conversation on a daily basis, and the logic and organization that you bring to problems that you face. And it really changes kind of how you do things, and it gives you a big toolkit, in your tool belt that you can not only face programming challenges with, but that you can face the world with. Okay, so we're actually going to get a little loopy, if you will allow me that dumb joke, which I can't help making. We're going to get a little loopy this time, and we're going to look at repetition. Okay, in this unit, so we're going to take a look at repetition. And in programming languages, those are often referred to as one of the ways you can do repetition. A couple of the ways you can do repetition have to do with loops. So we call them loops. And we're going to talk about two main types of loops, while loops and for loops. We'll also look at something called a do-while loop. In addition, in this unit, as I said, this unit really covers a couple of chapters. We're going to talk about arrays. And arrays are a way to have lists of things rather than just a single integer stored in a variable. We can have a list of integers that we can use to do things with. So, and not just integers, obviously. Lists of we could have a list of students, a list of whatever we want stored in an array. So we're going to talk about arrays, and then we'll talk about how we use loops to iterate arrays, to go from the first item to the second item to the third item, and go down and scan through the array. So we're going to learn how to do those kinds of things in this unit. As always, this lecture is an overview of the chapter. You're expected to move through the Zybook reading and participation assignments by clicking that link in Moodle and going to the assignment. And I suggest that you watch this video kind of as you go through the assignment, pausing the video to do the various participation exercises. I'd also like to point out that not that all of the sections aren't necessarily covered in these lectures. Sometimes the lecture will skip a section if it's just not appropriate for a lecture, or if it's something that, as we move forward, you're kind of expected to be able to read through and understand on your own, and sort of learn a little bit about how to learn on your own, because it's important that you do that in software engineering, because after you get out of here and after you move along, you're going to be expected to pick up computer languages and so forth on your own. So just a little bit of that as we go forward. So let's talk about loops just in general. A loop is a program construct, a structure that executes the statements inside the block in between the curly braces over and over again. As long as the loop expression, the expression that controls the loop is true, the iterations will continue. What's an iteration? An iteration is um, one movement through a loop statement. So each time you do the loop, you iterate it once, right? So it's sort of like do it once, that's one iteration, second iteration, third iteration. So when we iterate, something, we move through it doing something over and over again. So how do these loops work? Well, let's take this example of driving an infant around in a car. I'm sure some of you are parents, some of you may not be, but babies tend to stay awake and they tend to keep you awake sometimes. So one of the things that you can do that puts the little tykes to sleep is to drive them in your car. And so sometimes you'll see parents in the middle of the night driving around the neighborhood because it puts the baby to sleep. And so how might you do that? Let's say that we start here at the beginning and you have this, or here, and you have this car in front of your house. You put the baby in the car and you start driving up this way. And when you get to this intersection, you kind of check and you see, is the baby awake? And if the baby's still awake, you loop. You go see where it says true. If that's true, you're going to loop around and come back, and then you're going to check, is the baby awake? If that's true, you iterate again, you go around, and we just keep iterating the loop just like this, checking to see if the baby's awake until the baby is not awake, until that's false. When baby awake is false, we get to drive back home and go to bed. Okay? So that's generally speaking how these loops work. Let's say we write this program to calculate a sum. Okay, so here's some of our code right here. Sum equals 0, and then we get the next input from the user, the next number we're going to sum up or add together, and we place it in the value or val variable. Okay, and look, now we have a while loop, and it says while val is greater than or equal to -1. Okay, so -1 is a number that we're not going to add. Okay, it's a sentinel value. It's a value that tells you to stop the loop. So while it's not equal to -1, we're going to say sum equals sum plus value. Okay, so we're going to add whatever we typed in to sum and save it. And then we're going to get the next input. Then we go back up here and we check, is that input, that val, is that equal to -1? If it's not, then we add it to the sum. So obviously, if it's or is it greater than -1, not equal to -1? Obviously, what we're doing is we're summing positive numbers or 0 here. Okay, so we keep adding those sums together in this loop, collecting a new one, adding it in, collecting a new one, adding it in. And when the user gets tired of doing that, they type in a -1. And when that happens, we don't loop. We fall out and we just keep on going with the rest of our code, whatever happens to be down here. Put sum to output. We print it out. Okay. This time, we're going to calculate an average. So we need the sum variable. We need to sum up the items that we're typing in, the numbers we're typing in, and then we need to know how many of them there are. So that would be the num variable here, okay? And again, we're going to use this sentinel value of -1 to stop the loop. So val equals get next input. If val's not -1, then we'll start our loop. And we take that number, and what do? We're going to sum equals sum plus val. So we add val into our sum. And then notice what we're doing with num. Num equals num plus 1. Now, I usually don't use num for this variable name. I would use something like count, because what you're actually doing is you're counting the number of times that you go through the loop. Yes, it's the number of numbers that you type in, but it's really the number of times you're looping as well. So I like count or something like that. But anyway, sum equals sum plus value, num equals num plus 1. We could also write num plus plus there, right? Or num plus equal 1. Any of those things would increment num, which is what we want to do. We want to keep adding 1 to it each time we go through the loop. So we're counting the number of times that we go through the loop, and we're counting the number of numbers that we type in. Then we get the next input, and then we go back up here and check. One thing I'd like to point out, and then, well, we keep doing that. When you type in a -1, it falls out of the loop. You calculate the average. Average equals the sum divided by the number of numbers, the number of times you did the loop, and then you print the average. One thing that I'd like to point out, when using this while loop, before you enter the loop, you have to get an input, because you have to check. You have to check to see if val is greater than -1 before you fall into the loop body right here. Okay. Then at the end down here, after you use that first number, you have to get the input and then check it up here. Get the input and check it up here. So you actually have to have that in two places. And when you do this, you'll see the logic of that. You'll understand why it has to work that way. Okay, now let's think about this a little algorithm. We're going to talk about loops and a little bit of a list here and think about it. So how do you find the maximum value in a list of numbers? Let's say that you're just looking at some list of numbers and you want to figure out the largest number. Now, we need to think about this in terms of a step-by-step solution. If you look at this list on the screen, you just look at it and 22 jumps out at you. And you say, well, obviously 22 is the largest number. But what did you actually do? So it's sort of like you need to slow down your brain and think about how you did it. And what you did was you looked at all of the numbers in the list and you compared them. And then you said, oh, well, 22 is the largest one. But how would you tell a computer to do that? How would you do that? So think about it step by step for just a minute. Pause the video and just think about this. If you had to write out a set of instructions to me about how to do this, assume I can only see one number at a time, how do I do it? Okay, think about that. So here's really how we do this. This is the algorithm for finding the max in an unsorted list. Okay, so first we create a variable, and this is a list of integers. So we're going to create a variable, an integer variable max, a variable that can hold integers. Okay, and we set max to the first item in the list. So max eventually will hold the largest item in that list, right? So we have to consider one item at a time. So what we do is we set max to the first item, and then we look at the next item in the list. Is that greater than max? If it's greater than max, then we set max to the second item. Well, the second item in this list is not greater than max. The second item in this list is a 1, so max is still 7. We look at this item, 22. Is that greater than max? Yes, so we set max equal to 22. Then we look at the next item. Is 4 greater than 22? No, it's not. So max is still equal to 22. We look at this item, 9. Is 9 greater than 22? It's not. So max is still equal to 22. We look at this item. We compare it to max. Is 10 greater than 22? No, it's not. So max is equal to 22. There are no more items. So now max holds the largest item in the list. So that's an algorithm for finding the maximum item in a list. That's not an ordered list. All right, so let's look at while loops, basics. So there's a couple things you can do with loops. You can do things like iterate through lists and so forth. All right, so in this while loop, a while loop is a program that repeatedly executes a list of statements in the loop body. And you know, it's just like the body of an if statement. It's the opening curly brace and the closing curly brace. So if you look over here at this little construct right here, this is your while loop. And you'll see the keyword while, and then you see this expression. And then over here you see an opening curly brace, and right here, lined up right with it, is the closing curly brace. Okay, this stuff in here is the loop body. Okay, so we're going to enter this loop body and we're going to iterate. And what determines how many times we iterate is this expression right here. And what this says is while user character is equal to y, then keep doing this. So as long as this is true, user char equals y, you do another iteration, you come back up. Is user char still equal to y? Yes. So you do another iteration, you come back up. Is user char equal to y? No. Uh-oh, stop. And then you don't do the iteration and you just go down here and you proceed with the statements after the loop body. Okay, so what is this going to do? It's going to continue as long as you type yes. It's going to continue multiplying the current power variable times 2. Okay, so these are going to print out the powers of 2, 4, 8, 16, or whatever, that sort of thing. So that's what this is going to do. So if you look the way this works, we start right here with the loop body while user char is equal to yes. User char is equal to yes the first time because we had to set it that way. We had to set it to yes here so that when we hit this loop body, we'll go in there at least once. Now, if you use a do while loop, you don't have to do that, but we'll talk about that a little bit later. So while user char is equal to yes, system out print current power. So we're going to print current power. The first time through would be 2. Then we multiply current power equals current power times 2. So now current power is equal to 4. Right here we check, we scan in the next character. We can't scan in a character, right? Remember how to do that. And so if the character is a Y, we set user char to Y. That's the end of the loop body. We go back up here, user char is compared to Y. Is user char a Y? Yes. Then we do this again and we multiply current power, which was 4, now times 2, and so on. And we just keep doing that over and over again as long as the person types in a Y. If you type in anything else right here at this spot in this line of code, if the user types something else in, user char will not be equal to Y, and we'll skip the loop body and just go on. Okay, and that's the end of the loop, and we just move on down through our code, print out done in this case. So this slide has a dual purpose. One purpose is to show you how while loops work, but the other purpose is to show you how you might pick out individual digits in a number. Suppose you had an assignment and you had to determine one of the digits in a number. Say you had the number 213 and you have to pluck out a digit and compare it to something. So how do you get the digit out of there and print out all of the digits individually? 213 would be 2 would be the first digit, 1 would be the second digit, and 3 would be the third digit. Now that seems pretty simple, but it's not, exactly. If you want to, what's the second digit in that number, and you have to write code to figure that out, you could convert it to a string, get the second item in the string, and then convert the string back to a number, but there's a better way. And this is the way to do this with integers right here. And the way this works is with a while loop. So you input a user number from, an integer from the user, and you store it as user num. Okay, so while user num is greater than 0 right here, we print user num mod 10. Now what does that do? What does mod do? Remember, mod returns the remainder of a division. So say that you had the number that you're looking at is 101. If you do 101 mod 10, it's going to return the remainder, and the remainder of that division is 1 because 10 goes into 100 10 times evenly with 1 left over. So user num, if 100 mod 10 would return 1, and then you divide 100 and 1 by 10. Okay, so that division will give you 10. Okay, and then you go back up and you do this again. And if you do that over and over until you reach 0, okay, as long as user num is equal to 0, you do these operations over and over, it's going to print each digit in that number. It's kind of cool. You might want to take a look at it. Okay, and this little expression shows you, well, you can use a relational operator here. As long as user num is greater than 0. Now you need to make sure inside your loop that you're somehow decrementing or reducing the value of user num, or it just go on and on forever, right? It might never reach 0, so you have to make sure of that. Of course, in this one, we're dividing user num by 10, so we know sooner or later we're going to get down to 0 and this loop will stop. So let's look at that special kind of error, that infinite loop problem. That an infinite loop is a loop that never stops iterating. So a common error is to accidentally create an infinite loop with either a little logic error, a little logic problem with your math, or just by forgetting to increment or decrement a variable. It happens fairly often. So we start out with I as our control variable in this expression. The value of I is what's going to control whether we're in the loop or not, right? So integer I, we start with that equal to 0, and we say while I is less than 5, we're going to keep going in the loop. So, we have to make sure I grows, because, and eventually, reaches 5, our loop will never stop because it's going to keep looping as long as I is less than 5. So let's look at our code logic. Well, I is less than 5, and then we go in here and we say I equals I minus 5. So we subtract 5 from I, and then we print out I. Well, what's going to happen? I is going to get smaller and smaller. We keep subtracting 5 from I every time we're in the loop. It's never going to be 5 or greater, so it's never going to stop looping. That's an infinite loop. Okay, so you want to avoid that. The sentinel value, as I mentioned before, is a special value indicating like the end of a list or something along that line. So if we have a list of positive integers ending in 0, like 10, 1, 6, 3, 0, then we know that we're never going to have a 0 in that list of values that we actually want to use. Then we can use that 0 as a sentinel value. And if you look at the loop over here, it says while current value is greater than 0, as soon as it inputs a 0, that last 0 in the list, it's going to stop. Okay, and that'll be the end of that. Okay, all right. That'll be where the loop stops. There's another kind of loop called a do-while loop. So a while loop, you test for the control variable at the top of the loop. But with a do-while loop, you test at the bottom. So you do this stuff while, and in this case, c is not equal to n. So we have this character c, we have some integer I, and as long as c is not equal to no, we're going to just keep doing this. Notice c not equal with the exclamation point. And then we notice the characters are in single quotes, not double quotes, right? Okay. So we're going to do this. I equals I plus 1, system out, print line, variable I plus I, system out, print line, enter n to quit, any key to continue, and then c equals get the next character at 0. So get whatever you type in and make c equal to that. Put that in c. So if you type in an n, then c is not equal to n if you type in something besides n, c is not equal to n will be true, and you go back up to the do and you do it again. Now the difference between this kind of loop and a regular while loop is the test is at the bottom, which means you always do the loop body at least one time. So if you want the loop body to always happen once, you can use a do while loop. Okay, all right. Now, one kind of thing that we have to do with loops a lot is counting. So we might want to do a loop a certain number of times. Say we have a list of 10 items and we want to loop through that list of 10 items. We would want to loop 10 times. Now you do that with a while loop by putting a counter in the loop, right? So, while I is less than 5, I equals I plus 1 inside the loop. So let's look at the while loop here. So here we have this integer I declared, and then we say I is equal to 0. Now, while I is less than 5, do some stuff, and then increment I equals I plus 1. So now the first time I is 0, we reach this line. Now I is 1, we go back up. Is I less than 5? It is. So we do the stuff again. I is now equal to 2. We go back up. Is I less than 5? It is. We do this stuff. I is equal to 3. We go back up. Is 3 less than 5? Yes, it is. Now I is equal to 4. We go back up. Is 4 less than 5? It is. We go back down through. I is equal to I plus 1. So I is 5. Is I less than 5? No, 5 is not less than 5. So we skip the loop body and we're done. Okay. We iterate 0, 1, 2, 3, and 4. That's 5 iterations. 0 through 4 is 5 times something. It's 5 iterations, right? We always start with 0. Okay, so 0, 1, 2, 3, 4 is 5 iterations. We do it that way because that pattern is kind of the pattern that we remember, and we always try to do that so that we don't have to think about it every single time, how many times we're iterating. If I said, hey, iterate through this loop 10 times, that's fine. That's 0 through 9, right? So you have here, you'd have I equals 0, I is less than 10, right? 0 through 9, and that's 10 times, and the number of times would be right there. So if you do it that way, that's great. Gives you that number of iterations. Now, when you use a while loop to do this, you have to remember to put this start out with I right here to initialize I to 0. And then you've got your expression here, I is less than 5. So this is going to control how many times you're doing the loop. And then somewhere in the loop body, you have to remember to put in here to increment I. This is such a common thing. Counting these loops like this is such a common thing, and controlling your loop this way, that there's a little bit of a shortcut. Any kind of time you're doing a loop that counts like this, even if it counts by twos or it counts down, backward, anytime you're doing a loop that counts, you can use a for loop. And the nice thing about a for loop as opposed to a while loop is it's sort of like for this many times do this. The reason, the nice thing about the loop is that you put everything in one place, okay? So with a for loop, you initialize I right here, and you can actually put int I right there. You don't have to put it on a separate line. You could have like for integer I, int I equals 0, semicolon. Then here's the I is less than 5. That's this part right here. I is less than 5. And then here's the part where you're incrementing I. And you can put any expression you want in here. You can put I equals I plus 2, and you would just skip every other one, right? Or you could start with, a negative number and then, subtract from I, or do whatever you wanted to do. If you wanted to go from the bottom to the top, you can do that. We'll show you how to do that later. But anyway, so your other expression where you're incrementing is right here. So everything is right between these parentheses. Rather than just having the expression there, you have where you start, where you stop, and how you count right there in one place. And then it'll just keep doing the loop body until I is no longer less than 5, right? So here's a for loop, and we're going to compute the values, compute an average with this for loop, okay? And so we need to get the number of values in the list. We have to know that ahead of time in this case. So num values equals, and you type it in. So let's say that I'm going to average 4 values. I type in a 4 to get the number of values in the list. And notice there's no prompt here telling the user what to do. That's very bad form. You must have a prompt saying type in the number of numbers in your list. Otherwise, the user doesn't know what to do and the system just stops, right? So you must always have a prompt anytime you're inputting something. So that's not a very good example of the code there, and then the sum of the values is 0 to start with. All right, so we fall into our for loop. For I equals 0, I less than num values plus I, so we're incrementing I. That's the same as I equals I plus 1 right there. It's just a shortcut. So we're going to start at 0. We're going to increment I every time we iterate, as long as I is less than the number of values we typed in. So if we typed in 4, we're going to iterate 0, 1, 2, and 3, because we're going to stop, when I is 4, we won't do that iteration of the loop, okay? So we're going to input a value, current value equals SC, or SC in our next int, and then we're going to add it to value sum. And then once we reach 4, we'll fall out of that, and we go down here and we'll divide value sum by 4, the number of values, and print the average. And you'll notice that everything is a little less spread out here. We put all of those things in one place to control this loop, and that's the value of the for loop. Here's a for loop that finds the max. So we have our for loop. We input the number of values in our list, and we're going to go through the list. So here's one over here. It says 4 minus 1, 9, 0, 3. So we're going to run through those values, and we're going to type those values in, get the next value, and then we compare it to max, right? Each time. Remember, we look at 4, we input make max equal to 4, and then we look at the next one. Is -1, greater than 4? No, so we don't mess with max. Is 9 greater than 4? Yes, so we set max equal to 9. Remember that algorithm that we went through a little bit ago? Okay, so now we're actually going to implement the algorithm in code. So for I equals 1, I is less than num values, we have how many things on our list? 1, 2, 3, 4, 5. So for I equals 0, I is less than 5, plus I, that's the number of times we'll go through the list. Current value equals scan in the next int. So assume your user types in 4, and it says if I equals 0, that's the first iteration, then max so far equals current value. So that would, since I equals 0 the first time through, max so far will be set equal to 4, okay? And then we go back up and we do it again. Now I is equal to 1. I is incremented, plus I, increments I. So I is incremented, we put in our next value, which is -1. I is not 0, so we go down here, I is 1. Else if current value is greater than max so far, is this value greater than max so far? No, -1 is not greater than 4, so we don't do this. We go back up. Now I is equal to 2, okay? If I is equal to 0, it's not. So else if current value is greater than max so far, current value is 9, and that's greater than 4, so we make max so far equal to 9, and we go back up and do our loop again, okay? And that's how how it works. You just keep doing that till you reach the end of the loop, which is num values. That's the number of items in the loop, and that's what controls where you stop. All right, so we've implemented the algorithm that we discussed earlier for finding the maximum value of a loop, of a list. Okay, before we kind of start talking about how the loops work in this program, let's look at a couple of odd little things that help us understand it. So first, we declare a couple of characters. So remember lowercase char, that's one character. And the difference between characters and strings, a character is in, character literal is inside single quotes, a string's inside double quotes. So this is a string, 2-letter domain names, and it's inside double quotes. It's a string of characters. This is a single character, and it's inside a single quote, okay? And the data type is char for that. Now, I just want to point out, so we have letter 1 and letter 2 that are variables that contain these characters. And you'll even see on this line, letter 1 equals A. So letter 1 has the character A in it. I just want to point out down here, look at this, plus letter 2. That's like writing letter 2 equals letter 2 plus 1. Well, now how can you do that? How can you add 1 to a letter? And actually, it's kind of a quirky little thing that you don't see that often. So what are we doing here? What is that? Well, remember how letters are stored internally in the computer. They're stored as ASCII codes, right? Or Unicode values. So, character codes, standard character codes. So the letter A is like, I'm pulling this out of my top of my head, I think it's like 96 or 97. So that's what's stored in the computer. So if you increment that by 1, then it would be a B, right? So it's the next letter. So like capital A is 65, so capital B is 66, right? So if I add 1 to the code that stores the letter, then you get the next letter in the list. And Java is smart enough to figure that out and do that. You can actually increment a character and you'll get the next character alphabetically. I said in the list, but what I mean is alphabetically. Okay, so adding 1 to it gets you the next letter alphabetically. Adding 2 would get you the letter after that or something. Okay, so that's that little odd thing right there just gets you the next letter in alphabetical order. So let's look at this sort of loop thing. So one thing is nested loop. What does nested mean? Remember when we talk about nested, we're talking about something inside of something else. And with if statements, a nested if statement is an if statement that has an if statement in its body, right? Nested loops are the same thing. It's where you have a loop inside of another loop. And if you look right here, so you see the while loop here, and this while loop ends with this curly brace right there. And inside of that's another while loop. So we have an inner loop and an outer loop. Now, the thing to understand and the thing to really get into your head about nested loops is that for each time the outer loop does one iteration, the inner loop does all of its iterations. Okay, I'll say that again. So we're going through this outer loop and we hit the inner loop. So we do the outer loop, we hit this inner loop, and then it does all of its iterations here, bouncing back and checking, bouncing back and checking, bouncing back and checking until it's done. And then we go back up to the outer loop and we do its second iteration. And then this one does all of the iterations. Then we go back up here and do the third iteration, and this one does all of its iterations, okay? So for every time the outer loop does one iteration, the inner loop does all of its iterations. And they have both finish, and then you're done with the loops, okay? So let's look at how this works. What this does is it prints all of the two-letter domain names, aa.com, ab.com, ac.com, ad.com, and then going on down and then, you know, changing to B and ba.com, bb.com, all the combinations, all the way through. So how does it do that? So let's take a look at that. We set letter 1 to A, so we're going to start with A, and then while letter 1 is less than or equal to Z, okay, so we're talking alphabetical order, which is ASCII code. And then letter 2 we set to A, and then while letter 2 is less than Z, so let's walk through the code. You have to learn to step through the code, step by step, and that's what we're going to do here. So letter 1 is A. Is A less than Z? Yes. So letter 2 is A. Is letter 2 less than Z? Yes. So we print letter 1, letter 2. We print A, A. Then we increment letter 2. We're in this inner loop. We increment letter 2. So now letter 2 is B. Is letter 2 less than Z? It is. So now we print A, B. And then we increment letter 2, letter 2C. Is letter 2 less than Z? It is. So now we print A, C, and go on. We keep doing that until letter 2 reaches Z. So we're going to print AB, AA, AB, AC, AD, all the way down to AZ. Then we fall out of our inner loop because letter 2 is Z, and we go back up here. Letter 1 is now equal to B, right? And we go, let's set letter 2 to A. So now letter 2 is less than Z, and we say we print B, A, then B, B, then B, C, all in this inner loop until we get to B, Z. Then we go up here to the outer loop, and we're going to set letter 1 equal to C. And then we go on through again. And so you'll see every time this outer loop changes a letter once, we do all of the inner loop. And you can see it right here. When the outer loop sets the first letter, and the inner loop sets these, and then we switch, and there's the outer loop switching to B, and then all of them in the inner loop, and so on. That's how that works. Okay, nested loops is very common. It's how you iterate through tables. It's how you do math with matrices and that sort of thing. So lots of uses for this. Okay, so just a little extra thing here, variable name scope. So what does that mean? What is the scope? So the scope of a variable is the part of the program in which its name is valid. So if we declare variables in main, like right up here at the top of main, int usernum equals 2, int new num equals usernum, anything that's inside main can see these variables and use them. But if you declare a variable inside a code block like this, so here's this for loop, okay, and inside this for loop, here's the starting curly brace and the closing curly brace of the for loop, and here's the loop body. And notice right inside this loop body, we declare this integer name, okay? And the thing is since we're declaring it inside the loop body, and by the way, I'm not so sure this wouldn't produce an error. You might get an error that says that this variable has already been declared the second time you go through the loop. But just for the point of, so this is declared inside here. If you try to use this variable outside of this loop body, it won't be recognized. So if you try to use it and print it out down here, the system isn't going to know what you're talking about. This variable has the scope of between these two curly braces of this loop body. It can't be seen anywhere else. It's like a variable in one class can't be seen in another, right? So if you declared a variable inside an if statement, you couldn't see that variable outside. So it's just saying that's the scope of the variable. And a block is anything that's enclosed with curly braces like this, okay? Another little odds and ends sort of things, a break statement. So a break statement causes in a loop, causes the loop to be exited. So, if meal cost equals user money break, that'll immediately cause this for loop to stop and you'll drop out of the loop and go on down to the after the loop body, right? And notice how important, by the way, it is to use proper indentation, because I can tell, for example, that this if statement starts here and ends here. This is the ending curly brace. The for statement, the innermost for statement, this is a nested loop with two for statements. The innermost for statement ends right here. This is the outer for statement, and the outermost for statement ends here, right? So that tells me the structure of the code. I can glance at it, and because of the indentation, see what's inside of other things. I mean, I can see what's inside what. If this was all in a straight line right here, I couldn't tell. It would be very confusing. Anyway, break just causes the loop to stop. So if meal costs equals user money break, that'll jump you out of the inner for loop and take you to the outer for loop. In the outer for loop, they have something here. It's called if meal cost equals user money break. So it gets you out of there. So that's the idea of break. It's a different way of getting out of loops. Honestly, I rarely, if ever, use a break statement. I guess it's useful most of the time. If your logic's correct, you don't need it. And so whenever you feel that you must use it, I would kind of think about, well, maybe I need to rethink my code a little bit, that kind of thing. Okay, let's talk about enumeration. Enumeration can be a little bit confusing to begin with. And enumeration is a way to declare a data type, actually, that can only hold certain values. So, for example, a deck of cards can have only certain values. It can be a king, a queen, a jack, and it can only be a certain number of suits and certain numbers, that kind of thing. This is a little simpler. So this is a traffic light, and we're going to have in our traffic light, I understand they're going to change this soon, but in our traffic light, we're going to have green, yellow, and red. Okay. So we need to store this set of values, and we never want it to be we never want our variable to hold anything but these, okay? So here's how you do this. You declare it as an enumeration type, and the keyword is enum right here. So public enum, and then our identifier, which is actually, the name of it, of the enumeration, and then we have the values that it can actually have. Okay, so that takes care of chapter 5 and loops. That was a lot to wrap your head around in a short number of slides and so on, but if you work through the concepts in the chapter, you work through the exercises in the chapter and so on, you should have a fairly good idea about loops, and then when you do the labs, that'll kind of set them in your mind for you. Okay, so now a closely related concept in a way are arrays. And the reason I say that is that loops are very useful for iterating arrays. And what's an array? Well, an array is a list, and we kind of, in general, looked at how you might iterate through a list. So now we're going to look at it not so much in general, but exactly how you would do that. So let's look at at the concept of an array. We might have, you know, we might have a variable that we're used to like num players. So that's an integer variable, the number of players. And stored in memory for that is 12. So we're really used to doing something like that, right? Integer num players equals 12, and it stores 12 in a memory location in the computer named num players. So an array is sort of like that, but instead of storing one variable, one thing, we're going to store several of them contiguously in memory. And there's, in addition to calling this an array, some languages refer to it more like a vector. It's slightly different, but it's a similar concept. We're going to talk about arrays here. So what happens with an array? Well, say that we have an array, and the name of the array, the variable name is points per quarter. So we have this array called points per quarter. We could call it points, we could call it whatever we want to call it. It's just like any other variable name in some sense. It follows the same rules, lowercase first letter and uppercase after that for a variable name. And but it's not exactly the same. And the reason it's not is because points per quarter actually points to the memory location where we start a list of things. And we use index values to determine which item in the list we're talking about. So, for example, if we look at points per quarter, and then we have this opening brace and this closing opening bracket and a closing bracket, and then number 3 in there. This 3 is an index into the array. So points per quarter 3 is 28. Points per quarter 0 is 22. So each of these is its own integer value, okay? Stored contiguously right next to each other in a row. And each one of them is assigned an index so that we can get the one that we want, right? So this is 20 points per quarter sub 0 is 22, points per quarter 1 is 19, points per quarter 2 is 12, and points per quarter 3 is 28. And you notice we start counting at 0, okay? And that's all there is to arrays. Some people have problems with arrays. I don't know exactly why, but just think of it as one number right after the other, or one value or one item right after the other in memory, and you just number them, and that's it, you know, and you refer to them with this syntax. So the name of the array followed by the index value that you want to access or to change. Points per quarter sub 3 like this is just like any other. This is an integer variable. Points per quarter 3 is an integer. Points per quarter is an array. I hope that kind of makes sense. Maybe that helps a little bit. Okay. So when we need to have a list of things, we might have a grocery list, a list of strings. We might have a list of integers, a list of floating points. We might have a list of our person class, you know, a list of students. We'll learn how to do that a little bit later. But suppose we have to have this list, then we have to declare, we can declare an array. And arrays are only one way to do a list, but it's the first one we'll learn about. So the first thing we have to have is the data type of the things that we're going to store in the array. Arrays can only hold one data type. So you can have an array of integers, or you can have an array of strings, but you can't have an array that has both integers and strings in it. Okay, so only one or the other. You can have an array of floats, you know, so on, but you can't mix and match data types. For that, we use something different. Okay, all right, so you have to say the data type, followed by the braces, then the name of the array, and then equals new data type, and the number of elements that you're going to store in the array. So that's just the general way that you declare an array, okay? So this thing, this set of opening brackets after the data type, you can just read that as array. That's what tells the system that it's an array, okay? And an array reference variable, you can refer to different sizes. So let's look over here at the example. So here's our main method. Here's our class, public class array example. Here's our main method inside of our class. And then integer, and then the way that I read this, just in my mind, is int, and these braces I read as array. So int array item counts, and this is the variable name. So you're declaring this thing, item counts, as an array. This is your declaration, just like you would declare an integer, only this is an integer array because of those brackets. So integer array item counts equals, and we need new here, equals new int, and then 3 is the number of integers we're going to store in our array. That's the maximum number that it can store. Okay. So item counts can store 3 integers. We need the new keyword, and that requests that the operating system set aside space for our array. And item counts, actually, if you really looked at it, what it contains, what this actual word or label contains, it's the memory location of the start of the array. And that's what the operating system gives us. So item counts is just the memory location of the start of the array. Item count sub 0 is the first item. Item count sub 1 is the second item, and item count sub 2 is the third item in the array. Okay, so that's how you declare an array, and you follow that pattern. The data type of the thing you're going to store, followed by brackets, the name of the array, the new keyword, the data type again, and the number of items you're going to store in your array, the maximum number of items. Okay. So this code actually pretty interesting. It brings out a couple of important things. So just to get oriented here, let's look at it. These are the oldest people who have ever lived, at least up to when the book was printed. So we have the oldest person was 122 and died in 1997. Another person was 119 and died in 1999, and so on. And what we want to do is we want to print the nth person. Okay, so we're going to have the user enter in 1 through 5. So like this second person, you know, to second oldest person. So the thing you have to remember is we're counting at 0, right? So if nth person is greater than or equal to 1 and nth person is less than or equal to 5, print the nth person, the nth oldest person lived, and then where they lived. Now look, we're going to print oldest people. The oldest people is the name of our array. We've declared an array, integer array, oldest people that can hold 5 things. So we have oldest people 0 is 122, oldest people 1 is 119, and so on. So we've stored these ages in there. And if I want to see the second oldest person, that would be this one, oldest people 1, right? Because we started counting at 0. So the second oldest person actually isn't oldest people 2, it's oldest people 1. And this happens a lot. So when I print that out, print line oldest people, and I've stored nth person as the one that the user wants to see. I want to see the second oldest person, so that'd be nth person would have a 2 in it. I print out oldest people, nth person minus 1, and that's going to give me the second one, right? Nth person 1. The reason is we started counting at 0. So you just have to kind of remember that. These indexes must be integers, but other than that, you can do things like this. So oldest people, nth person minus 1, that's the index, nth person minus 1. So you can actually do a little arithmetic in there, and that's fine. That happens a lot. Okay. All right. So the really cool thing is using arrays with loops. So we can loop through the array. We can iterate the array and do all kinds of things to each thing in the array. So we can do different things to it. If you look here we, let's just kind of move through the code. You declare a scanner object, okay? Then we have this, we have a variable num elements, which is a constant. And when we make constants, we declare them as final, right? So final int num elements equals 8. It's capitalized, remember, because we capitalize constants, so we know that they're not something we can change in our code, that we know they're constant values. And then we declare this array. So this is an integer array. We're going to call it user vals, and it's a new int array with num elements, which is 8, right? The constant value 8. You know, if you put 8 in there, everywhere that you used or declared an array, you'd have to go through your code and change them all. If you put it in one place as a constant, you don't have to change them all. So that's one possible reason for doing it that way. Anyway, so we have this new array that can hold 8 things called user vals. And then we print enter num elements, and then for I equals 0, I less than user vals dot length. So when you have an array, you can use the dot operator, and length is a variable associated with the array that stores how many elements the array can hold. It doesn't store how many are in the array. It stores how big the array is, how many it can hold. You may have an array that's only half full, right? There's only half, you've only set half the elements, but say it had 5 things in it, but it could hold 10. Length returns the maximum number of items that the array can hold, right? So we're going to iterate this array. I equals 0, I is less than the length of the array plus I, okay? And again, as long as we just say less than here and not less than or equal to, this is going to work right. It's going to work correctly because the length of the array, the maximum number of items that it can hold, is going to be, say the length of the array is 10. That's actually 0 through 9 things, right? So we have to use the less than there. Otherwise, we'll overstep the bounds of the array and generate an error. All right. Then user val sub I is, you're going to ask the user to input a user value. So you're going to go through this whole array asking the user to input each one in this loop. Okay, so let's just step through the loop just exactly to see how it works. First time in, I is 0. I is less than user values dot length. Yes, user values dot length is 8. So then we increment, then we go down through, we input user vals sub 0, an integer from the user. And then we print user val sub 0, value user val sub 0. So whatever it is that the user typed in, we print that out. Now we go back up to the top of the for loop and I becomes 1. We increment I. Now we set user value sub 1 equals to whatever the user typed in. And then we print that out. And then we go back up here and we increment I. Now I is equal to 2. So user values 2 equals whatever the user types in. So as you can see, excuse me, as you can see, we're filling this loop with values from the user. We're iterating the loop, filling each value with one from the user. And the way that we do that is we just increment this index into the loop each time we go through, okay? And then we print you entered, and then we have another for loop, and now we're just printing all of the values. So the first time we drop into the for loop here, I is equal to 0, and we print user vals sub 0 right there. We go back up, now I is equal to 1, we print user values sub 1, we increment I, go back up, user values sub 2, and so on, all the way through the end of the loop. So you can iterate through arrays using, and all the way through the end of the array. So you can iterate through arrays by using loops to increment the array index. That's basically what's going on here. That's what's going on here. We're using the loop control variable to iterate the array index. What if I wanted to print every other item? Well, I can easily do that. All I have to do is, instead of saying plus I right here, or I equals I plus 1, I would say I equals I plus 2. And then the first time I go through would be 0. And then the next time I go through, it would be 2. And the next time 4, and so on. Okay. What if I wanted to go backward through the loop? Okay, I wanted to start with the last item in the last item in the array and go to the first item in the array. How would I do that? Well, I'd start with I equals uservals.length minus 1, which is the last item in the array. Uservals.length minus 1, that's would be 8 minus 1, or 7, which is the index into the last item in the array. And then as long as I is greater than 0, minus minus I. And that would go through the loop backward. Think about that, okay? All right. So you saw one way to initialize an array in a loop, and that's very often the way that you initialize the items in an array. You loop through something and you fill the array. For example, suppose you had, and we don't know how to do this yet, but suppose you had a file stored on your computer's hard drive and you wanted to load that data into your program. You know, you might read the file a line at a time or a data item at a time and store those items in an array, and you would do that in a loop. You use a loop structure to do that. And we'll learn how to do that eventually, but not right now. So that's not the only way, however, to initialize an array. So one of the things that we can do is, well, for one thing, when you use the new keyword, as we did in the previous slide, when you use that new keyword, all of the items in your array, all of the numeric items, if it's an integer array or a double array or a float array, all those will be initialized to 0. Arrays of Booleans will be initialized to false in Java, but it's always a good idea to initialize array items to the thing that you want them to be. So if you want them to be 0, initialize them to 0. And the reason that's a good habit is because not all languages behave the same way in terms of initialization, and some do no initialization at all. ANSI C language, for example, it's pure chance what appears in a variable after you declare it. You have to explicitly initialize it to whatever value you want it to be, or it's just whatever happens to be in memory at that location. That's what it would be. So you have to be careful about that with some languages. One way that you can initialize an array's elements with non-default values for small arrays, obviously you wouldn't do this for an array with 100 items or something, but you can use curly braces, and you can do it this way. You can say int, and then the brackets, my array equals, and then opening curly brace, closing curly brace, you put the items in there. So my array sub 0 would be 5, my array sub 1 would be 7, and my array sub 2 would be 11. And you can automatically initialize them that way if you want to. You don't use the new keyword because the array is set to the number of items inside these brackets. For larger arrays, you do it with a loop, the way we kind of looked at it before, just the way you printed it out or assigned it previously. So it's common to use these loop structures to iterate through arrays. And as I explained before in the previous slide, you know, we initialize I to 0. We use the array.length parameter to determine how big the array is, and then we just increment I to loop through it. And as I said, you know, if you want to skip every other one, you can do that. I equals I plus 2 or whatever. So that's just the general way that you loop through arrays, and you can start at you could make I equal to my array.length to begin with, and then loop backward, I guess you might say, from the last item to the first, that sort of thing. And inside this loop body, you have my array sub I. So I is controlling which item that you're looking at in the array, as we explained a moment ago. So we're iterating through arrays, and we can determine something about the arrays thing. So let's look at this program. And in this loop, what are we doing with the array? So we start with 0, I is less than uservals.length. So we're going to loop through each item in the array, incrementing by 1. And we're getting the user input right here, and we're putting each for each item in the array, starting with user val 0. We'll get user input, and the user can type in a value, and it'll go into the array. Okay. Now down here, we're going to sum those up. So we have a variable, our accumulator variable, sum value, where we're going to accumulate the sum. And we have this array starting with 0, I is less than user values dot length plus I. And then we have sum value equals sum value plus user value sub I. So let's step through this. I equals 0. So sum value is 0. So sum value is 0. We start our loop. I is 0. So sum value equals 0 plus user values sub 0. So that's the first item in the list. So we're going to add the first item in our list of values to sum value. Okay. And then save it as sum value. Then we go back up. Now I is equal to 1. So as long as I is less than user value's length, plus I, so I is equal to 1, sum value equals sum value plus user value sub 1. So we add in the next value to sum. And we just keep doing that, moving through, iterating through the array, adding each value into the sum. And then when we get to the last value and we're done, we print out the sum. Okay, so that's how that works, just like that. Work through a couple of exercises and you're gonna see how that works. We should be pretty familiar right now with finding the maximum value in a list. So now we're going to actually look at that with an array. So how do we do that? Well, again, we assign a variable max val or a variable max with the first thing in the list, and then we look at the second thing and the third thing and so on. And when we find one that's larger, we assign it to max. So you do the same thing basically with arrays. So this finds the maximum item, and we have a for loop that iterates from 0 to the end of the array, scans in the list of numbers, right? And then down here in this for loop, where we set max val equals, well, outside the loop, right before the loop, max val equals user vals, okay, that's the list, that's the array, user vals, sub 0, so the first item in the list. So we set max val to the first item in the list, and then we iterate through the list. If user value sub I, starting with 0, we could start with 1 right there. If user value sub I is greater than max val, then max val equals user value sub I. So we just look at each item, compare it to max val with the if statement, and if that item is greater than max val, we set max value to the value of that item, and we do that for every item in the array, and then we print out the maximum value at the end. Right? So that's how you implement that algorithm for finding the maximum value in a list. A common problem, a common error that you will see is this java.language.arrayIndexOutOfBounds exception. What does that mean? Array index out of bounds exception. It means you attempted to write something into an array or read something from an array that's past the end of the array. Okay, so if you look at this this little code snippet, you can see we have an integer array user weights that's set up to hold 3 items. So that's going to be 0 through 2, right? 0, 1, 2. Those are the valid indexes into that array. And if we attempt to go past that, we're going to get an error. So you'll notice user weight 0 is 122, user weight 1 is set equal to 119. So we're just assigning these values. And also just notice these are treated just like any other integer variable. They just are inside an array. So each one of these by itself you can think of as an integer. All right, so anyway, we're assigning these, and we go down here to this one, user weights 3 equals 199. And that's kind of a understandable error because we defined it to hold 3 things. But 3 things is 0, 1, and 2, not 0, 1, 2, 3. That would be 4 things, right? So this is past the end of the array, and it would generate this error. So if you see this, that's what's going on. Somewhere you're trying to move past the end of the array. One of the common structures or patterns that you see in code and that you will use in your code are what I call parallel arrays. So essentially, you have 2 arrays. One array holds some data, and the second array holds associated data. And the key thing is that each array item, the place in the array where the items are, has to correspond, right? So suppose I had an array of students, and then I had an array of grade point averages. So the first item would hold Janet's, array sub 0 says Janet, and then the other array, I have Janet's GPA in the 0 item. So each index corresponds between the two arrays. And here, this example, we have the weight of a letter. I assume that's ounces or something. And then we have another array, the cost. So letter weights, which is an array of doubles, and we've initialized it here with 1, 2, 3, 3.5, 4, so on and so forth. So these are the weights of the letters. And then for each weight, we have an associated cost. So the weight of 1, the cost for a 1 ounce, I guess, letter is 49. The cost of 2 is 70. The cost of 3 is 90. And you'll notice that these things must, their indexes must correspond. Okay. When you loop through them, you can loop through them at the same time using the same index value to print them both out. So if we look at our loop right here, it says for I equals 0, and then this is kind of interesting. It says for I is less than 1, or I'm sorry, I is less than letter weights dot length and not found weight. Okay, so if we find the weight, found weight is going to become true, and then that will make this false, and it'll fall out. Okay, so if letter weight is less than or equal to letter weight sub I, if user letter weight is less than or equal to letter weight sub I, then, found weight's true and so on. So basically, we're just going through and we're finding the weight that we want, and then we're looking in the cost index to get the cost. Okay, but these two things, these arrays have to be set up so that the index values correspond. That the first item is the first cost, the second weight is the second cost, and so on. Okay, those are parallel arrays, and that's how that works. And you just need to remember a lot of these things. You're not going to memorize exactly how to do them, but you know that the tool is there. So when you're trying to write your code and you're trying to do the lab and so on, think, whoa, wait, I have these two things, they're comparable, I need to use these parallel array things, and then you just kind of look up how to do it. Okay, and think about it think of these things as tools that we're giving you to solve these problems when you see them. A common thing to have to do is swapping two variables. Okay, really not swapping the variables, you're swapping the contents of the variables. So let's say we have a variable x that equals 33 and a variable y that contains 55. So why can't I say x equals y and then y equals x? Well, because when I say x equals y, I overwrite the 33 and lose it. Okay, so we have to use a temporary variable to store something when we do this. So I declare another variable temp or temp val, say it equals 0, Now temp val equals x means I assign the value of x into temp val. So 33 goes into temp val. Now I've saved that 33. I have it someplace, the previous contents of x. Now I can say x equals y and put 55 in x. Now x and y on this line both have 55 in them, and temp val has 33. So now I say y equals temp val, and I've swapped the contents of the two variables. So think about that. That's how you do a swap. Okay, swapping is something that you have to do in sorts and other places. So very often we're looping through an array, we're iterating an array in a loop, and we're changing each item in the array, or we're doing something to each item in the array. So just as a general pattern, how do you do that? Well, here's our for loop, starting at 0, going, as long as I is less than the length of the array, iterate by 1, I++. If user val sub I is less than 0, user val sub I equals 0. So if it's a negative number, make it 0. That's what this program does. It just goes through and substitutes 0 for all the negative numbers. I have no idea why you would ever want to do that. But the point is, this is how you iterate an array and change things in the array. There's an if statement inside the loop. Okay. Okay, so here are some additional material, various iterations for doing loops. And it's important that you kind of look over these, understand these, maybe type them in. You know, you can type any of this stuff in to Eclipse and run the code and see how it works. You know how to write a program in Eclipse, so you can play around with this stuff if you're not quite sure how it works. But here are some patterns for you that you can use to understand how to do these things. Okay. So this is something we've already looked at. For I equals 0, I is less than 5, I plus plus. So what's that going to do? It's going to start at 0 and it's going to iterate by 1. I is going to increase by 1 until I reaches 4, and then it's going to stop because when I is 5, it won't do the loop body, right? And this is going to print I. What does this one do? Well, this one will count from 0 to 4 by 2. So I is 0, it'll do that one. And then it's going to make I equal to 2, and it'll do that. And then it goes back up, I equals I plus 2, so I would be 4, and it does that one. And then I equals I plus 2, so I would be 6, and it fails that, so it doesn't do the next one, right? So that's how you would iterate by 2. Say you wanted to print every second item in an array. That's how you would do that, okay? All right. What if we wanted to count backwards? What if we want to start at the last item in an array and move backwards? So we want to count backward through the loop. How would we do that? Well, we set I to the last item that we want to look at, so I equals 5, and we keep looping as long as I is greater than minus 1, right? So that'll take us from 5 to 0. And then I minus minus decrements I each time. So the first time through the loop, I is equal to 5. Then the next time through the loop, I is equal to 4. And the next time, 3, 2, 1, 0. When it gets to minus 1, this is greater than minus 1. So when it gets to minus 1, when we subtract 1 from 0, we'll get to minus 1 and the loop won't take place. Okay, so that's how you sort of, quote, count backwards, count down from 5. So if you wanted to go from the end of an array to the beginning, for example, would be one use for that. Okay, and then if you look at this one, this is the same thing, except instead of this time, you're counting backward by 2's. I minus equal 2. I equals I minus 2. That's what that means. That's the shortcut for that. I minus equals 2. And then you're just counting backward from 5, and as long as I is greater than minus 1. So you're skipping every other one if you wanted to do that, for example. So this is just to show you how you can manipulate these expressions to move around, to loop in the way that you want to do the loop. Okay. And this is the same thing with while loops. So here we're starting at 0 and going up to through 4, iterating by 1. Okay. Here we're moving from 5 down to 0, subtracting 1 each time we go through the loop. So we also can define two-dimensional arrays. And a two-dimensional array is basically a table. If you're kind of mathematically oriented, you might think of it as a matrix. In any case, we define it with rows and columns. So if you look at this table down here on the bottom right, you can see that it has 2 rows and it has 3 columns. So when we declare our array, we tell it how many rows it has and how many columns. So we would do integer bracket bracket like this, 2 brackets instead of 1. That shows that it's a two-dimensional array. Here's the name of the array, my array, equals new. and then integer row column. And in row and column, we'll put the number of rows and the number of columns. So for example, if you look down here, integer myArray equals new int, and then 2 rows and 3 columns. So that defines essentially this table in the array. And if you look over here, you can see some code, and we can write some elements. We can put some elements in our array. So if we say myArray 0, 0 equals 55, that's the 0th row, 0, and the 0th column, 0. So that's this cell, 0, 0 equals 55. So we put 55 in that spot in our array. MyArray 1, 1, that would be this row, the second row, and the second column, 77. We assign that one with 77. MyArray 1, 2 would be the second row and the third column, 99. Okay, so that's how you declare a two-dimensional array, and that's how you access the values in a two-dimensional array and how you think about it. Finally, let's talk about enhanced for loops. So an enhanced for loop is basically a shortcut of a for loop. So a quick way to write a for loop, again, because you do it so often. It applies only to for loops that actually iterate the entire array. So it's can't be used for a loop where you're going to stop partway through. So here's the way that this works. So we have string array team roster. So this is an array of strings, and it's going to hold 3 strings. We can see right there. So team roster 0 is Mike, team roster 1 is Scotty, team roster 2 is Tony. And then we print the words current roster, and now we're going to print out all of the team members. So here's the for reserved word, and then string is the data type stored in the array. So string player name. And then this is the name of the array. And this will iterate through each item in the array, assigning the current item to player name, right? So you can print player name, and it'll do the first one, second one, third one, all the way through the end of the array. And that's exactly what it's for. So we've done it. We've done a lot. We've covered a lot. And you know, it takes a little while for all of this to settle in. So if you've worked on it a little each day, hopefully it hasn't been too onerous for you. So here's what we covered basically. We've covered loops and used a Boolean expression or a relational expression to determine when the loop stops. We've used counting variables with a control variable, or counting loops with a control variable like I. We've used for loops and while loops. And then we studied arrays a little bit, and we learned how to store lists of the same data type in our arrays, and how to get at those data types using indexes. We talked about parallel or multiple arrays so that we can relate information between 2 different arrays. We discussed two-dimensional arrays. We looked at how loops are used to iterate through arrays, and forward and backward in all kinds of different ways. So we learned how to iterate arrays with loops, which is really the power there of getting that done. And then that's something that's used all the time in almost every program. Okay, so this is great. We got a lot done this time. Basically, one more big chunk and we're finished.